Now, we have covered factoring before. We covered it when we covered quadratic last semester. We did cover this before, but I want to go over it again and kind of go pretty much do a refresher back on this, because the next chapter that we're covering is going to be over rational functions. And rational functions and rational equations are going to be expressions, equations that are dealing with having variables in the numerator as well as in the denominator. We're going to have variables in the top and bottom of a fraction. And whenever we deal with these here, we need to see if there are any like terms on top and bottom, and if there are, we need to be able to eliminate them. And for us to be able to do that, we need to go back over factoring and make sure that we have a good understanding of factoring, because it's going to make it easier to solve these. So what we're going to start off this week is going back over factoring and going back through that. And that's what we're looking at today. So today we're going to go over factoring, dealing with these here. Now, whenever we factor a polynomial expression, the first thing we need to look for is a greatest common factor. We're looking for a term, a number or variable that is common in all three terms. And we look at the first one here. Is there a term that is in common with b squared, 12b, and 20? Well, no, because there is a b that is in common with b squared and 12b, but not with 20. And 12 and 20 do have a like term, but b does not. We don't have one in all three, so that's fine. We just move on to step number 2, which is our two sets of parentheses with three spaces. So the next step in this here would be writing our two sets of parentheses with three spaces. First main step is to find a greatest common factor. If there's not one, we can move on to step number 2, which is to rewrite or write underneath the two sets of parentheses with three spaces. The next part is to find the sign that's going to go into both sets of parentheses. And really we're looking at the third term. If the third term is positive, then the signs are the same and they match the sign of the middle term. Now, if the third term is negative, the signs are opposite. So if the third term is positive, the signs are the same and they match the sign of the middle term. If the third term is negative, our signs are opposite inside the parentheses. So if we look at this here, Is the third term positive or negative? Positive. So if the third term is positive, the signs are the same and they match the sign of the middle term. Well, the middle term is also positive. So the signs would be positive and positive. Because if the third term is positive, the signs are the same and they match the sign of the middle term. Here the third term is positive, so the signs are the same. They match the sign of the middle term, which is positive, so they would both be positive. Any questions on this here? Our next step, the fourth step, is to find the factors of the first and third term. So our fourth step is to find the factors of the first and third term. So, if we look back at this here, well, the first term is b squared. Well, the factors of b squared are b and b. Because b times b would give us b squared, and that's the only set of factors that we have. Now, our third term is 20. Now, the factors of 20 are 1 and 20, 10 and 4 and 5, 2 and 10. So we can use 2 and 10, plug those in first. And our last main step is to check it to make sure we do have the correct set of factors. Now, when we check this here, the main ones that we're going to look at are b times 10 and 2 times b. We're not worried so much about b times b or 2 times 10. The other set of multiplications that we could do be these here. The reason we don't focus so much on b times b is, well, where did we get b and b? We got it from b squared. So they're going to multiply back to get to b squared, because that's where we got them from. 2 times 10 is going to multiply back to be 20, because that's where we got them from. They're the factors of 20. B and b are the factors of b squared. But the main one that we are focused on is getting back to the middle term, because the way we set it up will make the middle term change. Now, b times 10 is 10b. 2 times b is plus 2b, which gives us 12b. Is that the middle term that we wanted? So these here are the factors of b squared plus 12b plus 20. And that's it. Any questions on this here? Are you ready for the next one? Okay. So if we look at the next problem here, a squared plus 4a minus 32. The first thing we want to look for is a greatest common factor. Is there a greatest common factor between these three terms? Well, no. Kind of the giveaway is a squared and 32. Those don't have any common factors, so most likely there's not going to be one. So we can go on and write our two sets of parentheses with 3 spaces, our second step. Now that takes care of steps 1 and 2, which moves on to step 3, finding the sign that would be inside both sets of parentheses. They would be opposite because the third term is negative. When the third term is negative, our signs are opposite. When the third term is positive, the signs are the same and they match the sign of the middle term. Now where we put the plus and minus really doesn't matter. We just need to put 1 in each one. And then when we check it at the end, we can see if we got it set up correctly or we need to change it. Now we need to find the factors of the first and third term. Well, the factors of a squared are a and a. The factors of 32 are 1 and 32, 2 and 16. 3 doesn't work. 4 and 8. And that's going to be it, because 5 doesn't work since it ends in a 2, and 6 only works if both 2 and 3 are factors. And then 7 doesn't work either, and then we already have it, 8. Now, which one of these would we try first? 4 and 8. Which one do you want to put first? 4 and 8. And last but not least, we can check. A times negative 8 would be negative 8a. 4 times a is going to be plus 4a. And negative 8a plus 4a is negative 4a. Is that what we wanted? Did we get the correct number, though? Yes. So if we got the correct number but wrong sign, what can we do? Yeah, we can switch the signs. So we can change it from negative 8 to positive 8, and from positive 4 to negative 4. We flip the signs. Because if we get the correct number but wrong signs, we can just change the signs in the parentheses, and that should fix it. Try this tan. So if we do the multiplication again, a times 8 is going to be positive 8a. Negative 4 times a is going to be minus 4a, and 8a minus 4a is a positive 4a, which is what we wanted. So these here would be the factors. Any questions on any of this here? I have a feeling most of this is coming back to y'all from last semester, yes? Okay. It's a lot of guess and check, isn't it? Luckily, when we start doing this with rational expressions and our rational equations, the equations themselves will give us hints as to what the factors are going to be when we look at them. Let's look at this one here. Is there a greatest common factor between these three terms? Well, no. So we can do our two sets of parentheses with 3 spaces. Now, we don't necessarily have to write the spaces in. I do it to kind of give myself spacing. If you've got a good idea on the spacing, we can just put the parentheses. Now, the next thing we need to look is the sign. Now, for here, the third term is positive, 72, positive. So the signs are the same, and they match the sign of the middle term, which is negative. So we have negative and negative. Now we need to find the factors of the first and third term. Well, the first term is x squared. So we would have x and x. Now we need to find the factors of 72. Well, 1 and 72. 2 and 36. 3 and 24. Wanted to write 18, but that's later on. 4 and 132 would be 18. 5 doesn't work because it doesn't end in a 0 or a 5, but 6 does. 6 times 12. 7 doesn't work, but 8 and 9. So there's a good number of factors for this here. Which ones in particular do we probably not going to use or are not going to work? I'd say 1 in 72 is definitely not going to work because that's way too big. Yeah. I'd say at least these two and maybe this one here. Because if the signs are the same and we're adding or subtracting the numbers, they're only going to get bigger. Well, 18, 24, 36, and 72 are all bigger than 17. There's not any chance of it going down, decreasing. So looking at these other three, which one do we want to try? 8 and 9. Because what is 8 plus 9? 17. So we can do our multiplication and see. X times negative 9 is negative 9x. Negative 8 times x is negative 8x. And negative 9x minus 8x is negative. Is that what we wanted? Yep. So that right there is our answer. Any questions on any of this here? Do you feel pretty comfortable with this here? Okay. We'll go on and skip over to this one here. Because if y'all feel comfortable with this here, there's not a whole lot of use in doing those two because there's not any real difference between what we just did and those there. Just different numbers that we would use. But there is a slight difference in this one here. What's changed? There's a greatest common factor of 2. Because there is a number in front of r squared, but not only that, there's actually a greatest common factor of 2 across all of them. So that means we can factor it out. Because if there is a greatest common factor, we want to factor it out. We want to pull it out. Because it's going to make factoring it a lot easier. And whenever we factor a number in a variable or a variable out, we're realistically just dividing each term by whatever it is. So here we're dividing each term by 2. So 2r squared divided by 2 is just going to be r squared. 6r divided by 2 is going to be plus 3r minus 4. Because our 6r divided by 2 would be 3r, and our 8 divided by 2 would be 4. Now that we've factored all of our greatest common factors out, we can do our 2 sets of parentheses with 3 spaces. And our next step is to find the signs. Well, the third term is, so our signs are, one is going to be positive and one is going to be negative. Because our signs are going to be opposite. Any questions on this so far? Now we need to find the factors of the first and third term. So what are the factors of r squared? R and R, which I think we had enough of over the last 2 weeks, yes? Rest and relaxation. R and R. So the factors of r squared would be r and r. And the factors of 4 are, well, 1 and 4 or 2 and 2. Which set of factors would we want to use? 2 and 2. 1 and 4. What would the middle term be if we use 2 and 2? It would actually be 0. I said 1 and 4, and then I wrote 2 and 2 again. Now, with it being 2 and 2, the polynomial for that would actually be r squared minus 4. It's a difference of perfect squares. And if we check this here, r times negative 1 would be negative r. Caleb, let's focus in. 4 times r is going to be plus 4r, and negative r plus 4r is positive 3r, which is exactly what we wanted. So this here would be our answer. Now we need to include the 2 because it is a greatest common factor. It is a part of the answer, so we need it also. So you'll need the answer and our 2 sets of parentheses. Any questions on this here? We feel pretty comfortable with that there with the greatest common factor. It really doesn't change anything. We just have to factor that number out first. If we feel comfortable with that, we can go on and look at this one here. Because I put these additional problems in there if we need them, but if we don't, we can go on and move on. What makes this one different than the other ones? Yeah, the 3x and x squared are kind of in a different place, aren't they? Because normally when we factor this, we want it in standard form. We want the x squared first, the 3x next, and then the constant term last. We want it with the powers of the variables decreasing from biggest to smallest. And really, that's the only difference. Because from there, we can factor it the exact same way as what we've been doing. Because there's no greatest common factor, we can do our 2 sets of parentheses with 3 spaces. Now, since the 10 is negative, our signs would be opposites. Ones would be positive, one would be negative. The factors of x squared would be x and x. And what would be the factors of 10 that we'd want to use? It would be 1 and 10 or 2 and 5. So we can use 2 and 5. And if we check this here, x times negative 2 is negative 2x. And x times 5 is going to be plus 5x, which gives us a positive 3x, which is exactly what we wanted. So this here would be the correct answer. Any other questions on this here? Okay, so we're going to deviate from the note sheet a little bit. I added these 2 in because I didn't want to actually cover those next ones next. And when I say added them in, I mean I added them in about an hour or 2 ago. I printed these yesterday. So the rest of those on the note sheets aren't going to actually show up. So if you want to cross those out and write over the top of them, that's fine. So the p squared minus 36 isn't going to show up. So the first one, because we have this and one other that we're going to look at. Now looking at this here, is there a greatest common factor between 9x squared, 30x, and 6? 3. Because 9 is divisible by 3, 30 is divisible by 3, and 6 is as well, yes? So we can factor the 3 out. And if we factor it out, 9 divided by 3 is 3x squared plus 30 divided by 3 is x plus 2. Now from here, we can write our 2 sets of parentheses with 3 spaces. Since the 2 is positive, the signs are the same and they match the sign of the middle term, yes? So we would have plus and plus. Factors of 3x squared, well, we know we'll have x, and we'll have 3x and 1x. Because the factors of 3 are only 3 and 1. Now we also have the factors of 2. I'll just put it down as 1 and 2, because 2 only has one set of factors. And we'll delve into more of these with where the first term actually is x and 3x, where we have different factors tomorrow. But we'll look at this one here specifically. Now the next thing we need to do is to check it. Well, 3x times 2 is 1 times x is plus x, and 6x plus x is that what we wanted? No. Well, we can't flip the signs, but we can flip 1 and 2. And 3x times 1 is 3x. 2 times x is plus 2x, and 3x plus 2x is 5x. Is that what we wanted? Well, I could switch the 3x and x, but that's not really changing anything because it'll give us the exact same setup. So this part here is not factorable. That's as far as we can take it. But it is factorable in the sense that it does have a greatest common factor of 3. Now, it'd be nice to have a shortcut to be able to see if this does work, if it is factorable, yes? Let's use this here. The square root of b squared minus 4ac. This here is part of the quadratic formula. Because our quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. And it works out that if we plug this in, plug values of a, b, and c into this here and get a whole number, it's factorable in some way, shape, or form. So if we looked at this here, so b would be 10, so we'd have 10 squared minus 4 times a times c. Now this here, we can type the whole thing into the calculator, either one, because if I plug it into the graphing calculator and get a decimal, it's telling me it's not factorable. Or if we use the yellow calculator and it tells us that it's a decimal or has a radical or tells us that it cannot do it, it pops up an error, it means it's not factorable. Here, 10 squared would be 100 minus 4 times 3 is 12 times 2 is 24. And 100 minus 24 would be 76, which I looked this up earlier, which 4 does go into it. So does that come out to be a whole number? Well, no, we're left with that square root of 19, a non-repeating, non-terminating decimal, which is really telling me that that is not factorable. So the most that we can do is pull out a 3. So we can't necessarily say that it's not factorable completely because, well, we did factor out a 3. Questions on this here? Well, let's try this on this one here. Just the b squared minus 4ac to see if this one would work at all. Well, the value of b in this case would be 9. A is 5, and C is 2. So we're doing this here just to see if it'll factor. Now 9 squared is 4 times 5 is 20 times 2 is 40. Square root of 41 is the square root of 41. Because we could simplify it to a decimal, but it would be a non-repeating, non-terminating decimal. Now, is there a greatest common factor between any of these three terms? Nope. This tells us it's not. Well, we could do it at the start. It would tell us it's not factorable, but we do need to pull out that greatest common factor. Okay? Yeah. Any questions on this here? Now, seeing if we look back to this one here, so we see all that this one does factor down, yes? I'm going to erase this here. So our b squared minus 4ac. Well, the value of b here is 6. 4 times 2 times negative 8. Now 6 squared would be 36. Our negative 4 and negative 8 will make this positive. 4 times 2 would be 8, and 8 times 8 is 64. 36 plus 64 is 100, and the square root of 100 is 10. If we get a whole number, it means it will factor. So it's a kind of good way to check. But that is it. That is all we're doing today. All the homework this week will be all worksheets. Yes.